Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back. For this problem, well, let me start off with drawing my coordinate plane here. Sorry, it couldn't be a little straighter, but it'll work for our purposes, I hope. So we've got three vectors we're dealing with. One, which I will call force one. So we're dealing with forces here. Oh, actually, that's force two. Never mind. Here's force one right here. Force one points in this direction, forming an angle of 30 degrees with the plus y-axis, and has a magnitude of 21 newtons. So F sub 1. All right, now we get this vector right here, F sub 2, is along the plus x-axis and has a magnitude of 15 newtons. All right, so to balance these forces out, have the net force on our object be 0, we need to add one more vector. You can kind of tell by looking at this, if there's this vector right here has a positive y component, so our third vector needs to have um, a negative y component. And since both of these vectors point in opposite x directions, it'll be pretty close to having no x direction, but it will be kind of, there will be a little bit probably in this direction, this way, because this does appear slightly larger than the x component of this vector. So I will just kind of draw it out here. This could be wrong, could be right. We'll find out soon, hopefully. But it'll look something like that, I think. All right. So now we can do some exciting math here. We're going to, well, first of all, I don't really like this 30 degrees right here. We're going to turn it into a 60-degree angle with the negative x-axis. Doesn't really matter. So as long as you do the math right, you should still get the same answer, no matter which equation, which angle you're using. Just instead of using a sine, you're going to use a cosine, or vice versa, as we find the x and y components of f1. So the x component of f1 is equal to 21 times the cosine of 60 degrees. Or if you wanted to go bold and be rebellious and use the sine, it would be the sine of 30 degrees right here. So these are equivalent expressions, sine of 30 and cosine of 60. And that is going to give us an x magnitude of 10.5 newtons. All right, we're going to find the y component of f1 now. Oops, that was a little large. I'm going to draw that a little smaller. So the y component is equal to 21 times the sine of 60 degrees. That is going to be equal to 18.2 newtons. All right, so we can find out what this third vector, f3, is equal to by finding out, well, first we're going to find what the difference in the y components are right here. The difference between the y components of these two vectors is going to just be 18.2 newtons in the plus y direction, because this vector right here does not have a y component. That means f3 needs to have a negative, let's see, needs to have a y component of negative 18.2 newtons. I just realized this should be a negative right here. Right, because it's in the negative x direction as I define my coordinate system right here. the y component, oops, let's try that again. Here's f3, the x component is going to be equal to the x component of f2, which is positive 15 newtons, minus the x component of f1, which is 10.5. I guess technically that's a, well, let's see, we're trying to find the difference between these two vectors right here, because that'll give us what the magnitude, which should be somewhere about like this, of that vector should be. Which that is going to give us magnitude 4.5 newtons. And we can see from the drawing that this should be in the negative direction right here, right? All right. So if we want to find the magnitude of F3, we can take the magnitude, or the square, the sum of the square of its components. That is going to give us 18.7 newtons. To find the angle right here, this angle theta is going to be equal to the inverse, the arctangent of the opposite side, so that's the y component, so 18.2 over 4.5 newtons. So theta will equal 76 degrees. Oops. All right. And there are your final answers.